Students, in this session we are going to discuss a relative velocity in one and two-dimensional motion. First, what is relative velocity? Relative velocity means an object is moving in what speed. We are going to discuss the speed of the object in one and two-dimensional motion. That is, in x-axis we can say one-dimensional motion. The object covers both x and y axis. We can say it is a two-dimensional motion. Let me discuss briefly. Now consider the two objects A and B are moving with the different velocities. Then what about the velocity of object A? It is represented as VA and the velocity of object B is represented as VB. Therefore, the change in velocity or the motion of the two objects, what speed is known as relative velocity. So with respect to A and B, so we just compare with the two velocities. Okay. Now we are going to use some special cases for calculating the relative velocities. Case 1. In the first case, we are going to use one-dimensional relative motion. Okay. So here the two objects A and B are moving in a same direction with uniform velocities, which means both velocities will be same. Okay. Now we are going to calculate what is the relative velocity between the object A and B. Students, here when compared to object A with B, we have to consider the A as a first particle. Okay, so here the relative velocity of an object A with respect to B. So from A to B we are calculating the relative velocity. Therefore, the velocity VAB vector equal to VA vector minus BB vector. From the object A to B we have to subtract. Likewise, the relative velocity of object B with respect to object A. Here the B is compared with the object A velocity. Therefore, we have to subtract B from A. Okay. Therefore, VBA vector equal to VB vector minus VA vector. So this is the special case 1. What is the conclusion of this special case? Therefore, if the object 2 are moving in same direction, the magnitude of relative velocities of one object with respect to another is equal to the difference in magnitude of two velocities. Suppose the special case, the velocity is different from one another, not in uniform velocity. So from that, what is the greater velocity? From that we have to minus the lesser velocity. So that is the special case 1. Students, see the picture. This picture represents the example of special case 1. Here the two objects are moving in same direction but different velocities. Suppose you are calculating the velocity, relative velocity between these two. From the greater velocity you can minus the lesser velocity. Okay. Students, next special case 2. Now consider the same two objects A and B are moving in uniform velocities. Okay, the VA represents the velocity of object A and VB represents the velocity of object B. Now in this condition the two objects are in opposite direction, moving in opposite direction. So we have to calculate the relative velocity between this object A and object B. Now we see the relative velocities between these two objects. Now the relative velocity of object A with respect to B. In this condition, the object A will move in the same direction. The object B is the opposite side. Therefore, to calculate the relative velocity between these two, VAB vector equal to VA minus of minus VB. Why we are using minus B? Because it is to the opposite direction to the VA, so we are using the minus VB. Therefore, simplifying the formula, we get VA vector plus VB vector. So minus into minus becomes plus. Likewise, the relative velocity of the object with respect to object A. Now in this condition, from the B only we are going to calculate A. Therefore, minus VB minus of VA vector. Now taking the minus common outside, so we get minus of VA vector plus VB vector. Okay, so this is the special case 2. Now coming to the conclusion, if the two objects are moving in different velocities in opposite direction, therefore the magnitude of the relative velocity one object with to another is equal to the sum of the magnitude of the different velocities, which means you are going to calculate the relative velocity, so you have to add the two velocities. Okay, so the formula itself we know VAB vector equal to VA vector plus VB vector. Likewise, VBA vector equal to minus of VA vector plus VB vector. So we have sum of the two vectors which will be equal to the relative velocity. Students, in case 1 and case 2 we discussed an object moving in one dimensional. In this case 3 we are going to discuss the two dimensional. Okay, now consider VA vector and VB vector are the two velocities of object A and B moving with an angle. Okay, so the A moving in X direction and B moving in Y direction, making an angle theta. Now we are going to calculate the relative velocity with respect to A to B. Therefore VAB vector equal to, we know the formula, VA vector minus VB vector. Now we have to calculate the magnitude. From the triangle law of vectors, that is addition of two vectors, the magnitude and the direction will be calculated. So VAB vector is calculated. The VAB equal to square root of VA square plus VB square minus 2 VA VB cos theta. So this is a magnitude. Then we are going to calculate the direction, that is tan beta equal to VB sin theta divided by VA minus VB cos theta. Here the beta, that is the angle, represents the velocity relative between VA vector and VB vector. So this is the third case when the two objects are moving in different axes, that is cover X axis and Y axis. Students, for the special case 3 we are going to implement one example. Okay, now consider a person moving horizontally with velocity Vm. So here Vm represents the velocity of the man moving in a X direction. Now let the rain fall vertically with the velocity Vr. An umbrella is held to avoid the rain. Then the relative velocity of the rain with respect to the person we are going to calculate. First you see the diagram. The figure represents the person moving in horizontally during the raining. The velocity of the man is in x-axis, the velocity of rain to downward vertical axis, that is y-axis. To calculate the velocities relative between velocity of the man and velocity of the rain, so we know the formula in the case 1. The relative velocity between rain and man. Okay, so Vrm vector equal to Vr vector minus Vm vector. So next we are going to calculate the magnitude. See the derivation. For calculating the magnitude, we know the formula from the addition of vector. Vrm equal to square root of Vr square plus Va square minus 2 Vr Va cos theta. Here the Va and V are making an angle 90 degree, therefore theta equal to 90. Since cos 90 equal to 0, substitute in the formula, we get Vrm equal to square root of Vr square plus Va square minus 2 Vr Va into 0. Then anything into 0, 0. Therefore, we get Vrm equal to square root of Vr square plus Va square. Next, we are going to calculate the direction. To calculate the direction, we know the formula tan theta equal to Vm sin theta divided by Vr minus Vm cos theta. Again, the theta will be equal to 90 degree, sin 90 value is 1 and cos 90 value is 0. And substitute in the formula, we get tan theta equal to Vm into 1 divided by Vr minus Vm into 0. And finally, we get tan theta equal to Vm by Vr. We need only the angle, therefore the tan will be moving the opposite side. We get theta equal to tan inverse of Vm divided by Vr. Using the magnitude and direction, we can easily calculate the relative velocities between the two objects. Now, coming to the conclusion of this special case, when the man is moving horizontally without falling rain on his body, at what angle he should hold the umbrella? Using the calculation, the magnitude and direction, the angle theta will be 90 degree. So then only he is safe in the rain. Therefore, we have to hold the umbrella vertically. Okay, that is the umbrella in the angle of 90 degree to the horizontal. Then he is the safe. Students, now we see one example problem related to this example cases. Consider two trains A and B moving along a parallel track with the same velocity. That is, they are moving in a same direction. Okay. Now, the velocity of the each train, okay, 50 km per hour due east. To the east, the two trains are moving in same speed, that is 50 km per hour. So we have to calculate the relative velocity of the train. Now, first you write the given data. So the velocity of the train 50 km per hour. Okay. Now to find the relative velocity, we know the formula for finding the relative velocity. First, with respect to B with A, the relative velocity formula is VBA vector equal to VB vector minus VA vector, and substitute the values, that is 50 km per hour VB and VA also 50 km per hour. The both are minus and we get 0 km per hour, that is VBA vector equal to 0 km per hour. Likewise, the relative velocity of A with B, the formula VAB vector equal to VA vector minus VB vector, and substitute the data 50 km per hour minus 50 km per hour. So we get 0 km per hour, that is VAB also we get 0 km per hour. So what is the conclusion of this problem? The both trains are at rest. Okay, from the B to A or A to B, both are at rest. Students, example 2.27 and 2.29 or take homework. Now coming to example 2.29, just to give one clue. The question is given in kilometer per hour, so you have to convert into meter per second. Okay, the velocity is calculated only in meter per second, so they are represented in kilometer per second. So just do it carefully. Okay, in second video we discuss another some important basic concept of kinematics.